All right, I just want to do a quick sound check while I get the stream up here. If you guys can, let me know that you hear me. That would be fantastic. All right, I just wanted to... Okay, and it looks like there's a solid 10-second delay between the live and YouTube here. All right, so good to know. Let's see here. Let me make our announcement in Discord here. Is there a link to this? Let me see here. Gosh, it's been so long since we've been on YouTube. It has been some time. Okay, give me 1 second here. Let's see. Hold on, I'm just posting in our Discord channels that we are going to be answering live Q&A and working on some code stuff. Hang on. Okay, hang on, I'm just posting in one more channel here. We got our normal Game Dev HQ servers. Hey, what's going on, Mark? How's it going? Hey, Dennis. Hey, Kuya. How are you? Okay. Okay, cool. So let me show you guys what we're doing here. Basically, if at any time, by the way, you have any questions related to Unity, C#, you want to see a demonstration of something, feel free to just ask. Happy to tangent like crazy. We'll be streaming for several hours today because I'm working on we're working on this no-code Unity intro course, and the last part of this is creating interactivity. Hey, how's it going, Jared? Hey, Armand. And for the interactivity part, let me share my screen here so you guys can actually see this. Okay, so for the interactivity part, the purpose of this is that we don't want to get into coding right away. We want to just demonstrate interactivity opportunities within Unity. So for example, I've created 2 scripts that are working currently, and you can think of this as if think about how visual scripting tools work underneath. Essentially, when you create a visual scripting tool or a visual script in Unity or Unreal, it is creating the equivalent code file and it's working behind the scenes on what it's doing. I'm not a fan of visual scripting, and I don't think we should be teaching it, honestly. If you work for a company that does visual scripting, it's very easy to adapt to it and pick it up. So instead, what I wanted to is to demonstrate Unity's component-based system is I want to have the ability, for example, to drag and drop game interactions. So for example, here's a move component and here's an update color component. And on that move component, I can choose the direction that we want that cube to move. You can give it a speed or whatever game object it is. And then on this update color component, you can select a color and then you can choose what key press is going to initiate that color change. So for example, we can open that up, we can click on space, and let's save our scene. If we run this, we should have a cube that moves to the left because that's what's being told. If I hit the space key, it turns blue. Once it goes off screen, it's then going to delete that cube. So the purpose of this is to create interactions that someone who was brand new to Unity could potentially maybe build a simple game using these interactions. So what I want to do in real time is I want your ideas on what we should add, and we'll code them up together here. We'll take a look. So the next thing I was working on was a WSAD movement script. And since we're on stream, I'm going to try my best to make everything production best practice ready. That includes using namespaces, which I did not do in move or update color. So we will fix that. But here's our code. Let me see here. Hang on. Okay, cool. All right, so, and I'm just gonna, can I pop this chat out? I think I can. Oh yeah, pop out chat. Oh, much better. I think I can now close this or minimize that. All right, good deal. I got the chat popped out and our Streamlabs is up. Okay, sweet. All right, so inside of here, let's update these namespaces first. So the first thing here, we're gonna do namespace. Let's get inside Game Dev HQ. All right, and then basically we're just gonna grab all of this and kind of move it in. Alrighty. And here's a quick trick in Visual Studio. You see how the indentation is off on this? If you actually close that, if you remove the last bracket and add it back, it should automatically indent everything for you. Just like it did. All right, so here we go. So we got our namespace Game Dev HQ, update color. Here's the code for how that works. Everything looks pretty good. Something that we might need to do is if someone were to accidentally remove a mesh renderer, so we might need to require that component on this. So I'm gonna use an attribute here called require component, and then you can do type of the component we wanna require, which is the mesh renderer. And then let me see if there's anything else I can spot on the move. For the move, it just requires a transform, which you can't delete, so we should be okay there. It basically just translates based on the direction, and then on became invisible destroys that object. And let's move that into the namespace for Game Dev HQ. Okay, grappling, I have trouble with that. Grappling, like creating like a grappling gun? Like a swing animation or something like Spider-Man. Let's see, move that into here. All right, cool. All right, so we got our move class, update color, and then here I'm just working on the WSAD movement. Let me know what other drag and drop interactables could we potentially create here. Think about that. Like I put this script on a game object and you have customization opportunity over it. Like what else can we create? Hey, how's it going, Mr. Cody? All right, let's go ahead here. We're gonna create our movement. So when you attach this movement script, we want to make sure that the player can, give me a second here. Let's namespace this. Okay, so here we go. So we got our WSID movement in here. The first thing here is they need to be able to like define the speed. So private float move speed. And by default, we'll set it to like 5.0f. All right, and then inside of here, all we have to do is just check for that user input, right? So essentially, we can do input.getAccess. We'll grab the horizontal, and we'll grab the vertical inputs. All right, and here's your vertical. And then here we specify basically the direction to move, right? So we can say var direction equals a new vector 3. And that direction is going to be along the x and y axis. So we're focused only on a 2D aspect. Z, it will always be 0. Once we have that direction defined, we can then move by that direction. So we translate by that direction. We pass in the direction, we multiply it by the move speed, and we include time.delta time. Hey, what's up, Jason? How's it going? I think that's Jason's story from Infallible Code. How's it going, buddy? Tom Fox is on, sweet. Tom Fox is Director of Engineering at Game Dev HQ. Introverted Zombie, Control KD should be auto indent. Nice. Yeah, I always just remove that last bracket. All right, cool. So basically we got our move speed here. We want to make sure that it's editable in the inspector. And this is a pretty simple one. So let's go ahead. I knew this one was going to be easy. I'm going to remove these attachable components. Let's just make sure we test this out. You can see here that we do have an error, so we'll just double click it. The name Y does not exist. It's actually going to be vertical inputs. Something that might be interesting is to allow the end user to decide if they want smooth movement or fixed movement. So instead of going a float value from 0 to 1, it just snaps. So right now we kind of have like this acceleration movement, but we could snap it using input get access raw. But we basically have movement, and that was the important part here, is allowing them to just, hey, you can attach the script and you get movement, all right? The purpose of this is that this person knows zero coding and they want to be able to build interactions in Unity. So what can we apply or build here? Oh, okay, cool. Jason Story's got his own YouTube channel now. Awesome. Tom Fox, I'm not sure if you're raising your hand or you're just waving here. Let me see. I can't. Let me open this. Yeah, okay. All right, good deal. All right, what's another kind of packet that we could create here that's an interactable that you could just drag on? So far we got our move, we have an update color interaction, we have a WSAD movement interaction. I feel like we should include a position updater, like being able to set a position of an object potentially. Super easy, but you never know how it could be, it could be used. Kuya, what'd you say? I already said hi to you, Koyu Koopa. No, I read everyone. All right, so let's see here. Move, update color, WSAD movement. What should we do? Let's add here just a simple one, get the juices flowing. Let's create that positioner one. So here, we'll call it set position. And essentially what we want to be able to do with this is the game object that you attach the script to, you can specify a starting position, and maybe after a delay we can incorporate like other positions. I don't know what game mechanics we could create with that, but for this one here, pretty easy. Set position, we can essentially just say, hey, we can either take in a game object or a vector3 for that. So we just say vector3 position, we'll serialize it. All right, and this one's just super easy. Take the transform position and set it equal to the position that they want it to be at. Standard spawn a primitive, add a rigid body and force is a staple. Yes, agreed. We're gonna get into spawning. Let's do a spawning one now. Or a raycast grounder, place a floor plane, have it snap to the ground at start. Ooh, that's a good idea. Ooh, I like that one a lot too. All right, we're gonna do both of those. Good suggestions, Jason. All right, so we got our position here. Private void start transform.position equals that position. This is just a simple positioner thing. So if they, for some reason, wanted to attach that component, they could. Let me just put this in the Game Dev HQ namespace, and okay, that looks good. All right, so let's do a simple spawn one here. So we'll call this a spawner. Spawner, yeah, I'm trying to think if we should, if you wanted to spawn multiple objects, how could we create this in a modular fashion? Should they attach multiple spawn components to a spawn manager game object, where each spawn is responsible for that individual game object? Or should we allow the concept of like an array of objects, but then we need to be able to give them rule sets for how frequently on each of those objects? I think we're gonna start with a spawner that is uniquely individual to whatever object you wanna spawn. And we'll go from there. So let's just set this up. And the first thing that we're going to do inside of our spawner is we need a game object prefab that we're going to spawn. So we'll create that game object, call it prefab to spawn. We'll serialize it so that they can actually assign that. Once you can assign a game object, essentially the way I envision this working is they will create a spawn manager, because they'll know how to use game objects and create game objects, and they will attach a spawner script to it, which will then let them decide what prefab to spawn, and maybe we can set position to spawn it, and we can actually incorporate the raycast check for is there a ground and snap it to that position if we want. Let me see here. I personally favor a spawner script with the spawn method than a script that takes an array of them and a rule to apply round robin all at once a random number of them. Ooh, great suggestions. All right, let's make it work like this. All right, so I personally favor a spawner script with the spawn method than a script that takes an array of them. Okay, so basically what we're going to do is we have this spawner object, and we're going to create an array of these objects, and we can apply rule sets to them. That's a good modular way to do this. Okay, so we got our spawner, and we need to we have the prefab to spawn. Let's allow them to do an individual location to spawn. And we might want to make that a game object that they can actually like transform position, for example, like put in a spawn point, essentially. So let's make that a transform. We'll call it a spawn point. And if that's null, then we will use a raycast and go towards like a plane or something. Let's see here. We got our transform spawn point. And then let's also allow them to specify how many to spawn. All right, we'll call amount. All right, amount to spawn. And then we should be able to do this. So inside of start here, we're going to instantiate. If we need a reference to those objects, we'll create them at that time, but let's see here. So instantiate, we're just going to basically take that spawn prefab. So prefab to spawn at the spawn point. And for now, we're gonna assume just quaternity.identity for this, because they're too beginner to get into different rotations on this, I imagine. Let's see, prefab to spawn point. Dot position. All right, so let's see here. So we just instantiate that object. Now, what we need to do, though, is loop through the amount to spawn, right? So here, we're just going to do that. So parent I equals 0, well, I is less than the amount to spawn. All right, and we'll go ahead and do this action that many times. All right, cool. So we got a spawner script, prefab to spawn. Let's just go ahead and prefab up this cube real quickly, and we should have a functioning spawner. So this cube, and we can go ahead and put, let's go ahead and let's put a move script onto this. Let's put a move component here, and let's say the direction is going to be down. We'll create a 3D object to represent our spawn point. And why can't I actually see that? -10. Okay. There we go. Up here, we'll go ahead and just turn off the mesh render for this and the collider. We're just using this as a spawn point. And we actually might be able to create varying spawn points potentially too. But here we got our spawn point. And on this cube, we have that. It's going down. Okay. All right, spawn manager. We have a spawner script. We're going to go ahead and attach that cube prefab. We're going to attach the spawn point, and we're going to create 3 of them. The problem with this is all 3 of them, they're not going to be spaced out. So if they ever wanted to do this, chances are they want some sort of delay, right? But we do have 3 of them spawning out, and all 3 of these guys are going to delete themselves in a minute. Let's see. One warning about the amount to spawn. If it spawns inside themselves as rigid bodies, the explosion can be confusing. I recommend a random .onUnit sphere call to reset to offset the positions. Yeah, so we could definitely do that. The problem is assuming that they're gonna want forces to be enabled here. Potentially we can create a physics component that enables physics for them so that we know to behave that way. Let's see here. So we have, let's see, on our spawner, prefab to spawn, spawn point, amount to spawn. We instantiate prefab to spawn, spawn point positions. Do we want to interpret some randomness or preventative of stacking? That's the question. I don't know. Alternatively, what I'm thinking they could do is from the spawn point, maybe the use case of this would be from the spawn point. So if I have a spawn point over here, essentially I can put a spawner there, and I guess they could do that, right? Like they could reorganize, I could put a spawner here, and now we have basically 3 spawn points. And I forget how it works. Unity has these, how do I do the flag system? They like changed it, I think, in 2021, where you can put like icons on this stuff. I forget where that is. I thought it was, oh, here it is. Okay, here we go. All right, good deal. Spawn point. All right, so we got these 3 spawn points in our game here. And essentially, each one of these would have a spawn point. And we can actually assume that that spawn point object, and maybe we can prefab that for them, right? Is here's a spawn point, it automatically has a spawner, and you can update it. So we can actually remove the spawn point unless you wanted to override that spawn point, which I don't think we should allow them to do. So we got prefab to spawn, the amount to spawn, and then obviously it's just going to be transform.position. So this lets them set their individual spawn points where they want, and you can choose how many objects from that spawn point you want to create. And let's just multi-edit this, add in the cube. All right, we'll spawn 1 for now. All right, and that cube has a move down thing, and so everything's going to move down. Let's see. Yasha, what's going on? I'm having issues with networking, particularly my host works fine, but the remote client doesn't move with a moving platform, not child of the platform. That sounds like you have an RPC call missing or something. You might need to, my host works fine, but the remote client doesn't move. That means that the remote client is not sending back to the from the server the updated positioning of that. So most likely it's a procedural call that's being missed. Also, if you're using something modern with Unity, there should be a sync transform component that would instantly fix a lot of those problems. Let's see here. All right, hold on here. All right, cool. Let's see here. Trying to think if we are good enough. The goal here to know if this is successful is, let's imagine I wanted to create a simple space shooter of concept, right? Could I do that using just these clickable components? I think if we have an end goal in mind, it could help us create the components we need. So right now we have spawn positions. We can modify this spawn point to create recurring spawns, and then we can create like a custom editor to only display the options for recurring spawn information if a bool is checked potentially. Maybe we'll do that. Let's see. Introverted, looking forward to starting with you all soon. Got my learning action plan. Awesome. Dude, introverted, great. Let's see. I'm just trying to think what we should foreshadow on this. Let's look at this. So here we have individual spawners, prefab to spawn, amount to spawn. And maybe we can add a frequency, right? So if the amount is greater than 0, we can use that frequency. Let's do that. So right now it spawns the objects based on that frequency. And in order for us to do this, we just basically are creating a cooldown system here. So on the underneath of this is basically going to be a float. We'll say next spawn, and we'll set that equal to -1. And then here we have our frequency, which is the 1. So that's already like our delay. And then inside of here, when we run this code, this will need to actually be done inside of essentially update, I think. Frequency, amount to spawn, and we'll create a looping functionality too for this. But essentially what we're going to do from start is we'll probably need to call or execute a coroutine or turn this into a coroutine. So here I enumerator, and actually then we don't need this at all. What I don't want to do is I don't want to put this in update, because especially once we're done spawning, we don't need to be in update anymore. So I think we're just going to do a routine for this. We'll keep the frequency. And then basically for each object, the frequency at which we spawn them, we're going to delay that frequency. The question is, do we spawn immediately or wait the frequency? That I don't know. And we can just put the frequency in here. Something in a production environment that's not crazy optimal, but still optimal, is to cache this wait for seconds here. So you could actually do something like, you could do wait for seconds. Let's call it frequency delay. And we basically allocate the memory for this right here. Field I cannot use static. It doesn't. It's angry that it's angry that it's right there. Hang on. We have our frequency delay, and then here yield return frequency delay. And I think we can just, can I open that up? No, I can't. Hold on. I gotta Google how to do that. I forget how to do that. Let me see here. Let's see, C# coroutine, wait for seconds. Let's see, I want to see someone who's, okay, here we go. Okay, yeah, new wait for seconds. Oh, okay, it doesn't like that I'm using that object initializer, so we'll actually have to use void start for that, which is kind of annoying. All right, so we'll assign it right here, which is fine. All right, so here we have wait for seconds, a frequency delay, and then we have to initialize that frequency. So in start, we're basically going to say, hey, your frequency delay is equal to a new wait for seconds. It has to be within a method to do this. So now we can actually say, hey, it's going to be the frequency that the end user set, and then yield return frequency delay. So it's going to wait 1 second, and it's not going to allocate any new memory for us to run this. All right, so here, based on the amount to spawn, we instantiate a prefab, and then here we simply say yield return frequency delay. So that's going to give us our delay. We don't have a looping mechanic yet, and we might want that, so we'll support that next. But let's just test this out, make sure everything is good. So let's look at this middle spawn point and set the amount to spawn to like 5. We'll delete this one. All right, there we go. So we got our spawner here, and then it stops. So we can have a option here to repeat, I think is what we should do. Loop, essentially. So we'll let the end user check that to be true. If it is true, right? So if we're gonna loop, essentially what we want to do is get us into a infinite loop here for this. I think we can actually do that right here, where it's basically going to spawn through all the amounts, and then it's just going to restart that process. It will restart that process if it is true or not, right? So here, we can essentially just wrap this in here. So here, if loop is equal to true, and actually I'm trying to avoid duplicating the code here. I think I might have to. We'll put it into a function to avoid that duplication, but essentially, while loop is equal to true, what's gonna happen? We're essentially just gonna do this forever, right? However, if you're not gonna loop for true, then we wanna do it at least once, right? So this is where a do while loop can come into play. So let's do that. So we're gonna do a do command, which is automatically gonna do it at least one time. And then here, while, we're gonna say looping is set to true. So we're gonna do all of this code while loop is set to true, and then to clean it up a bit more, we can actually create a spawn. We can create a spawn code if we wanted to, or a spawn method here, but I think we're okay. Let's test that out, and we should have the ability to loop this. All right, so spawn point in the center. All right, so we got 5 over here, and let's do 1 over here, but let's check loop to true. All right, we just need to serialize it so we can see it in the inspector. And there we go, we got our loop. Let's say prefab to spawn, amount to spawn, frequency, and loop. Let's run it. All right, and there we go. So the left side's gonna stop after 5, but the middle is gonna continuously spawn. So I think we would be able to use this as our spawner for whatever it is that someone is trying to create a simple game out of. I think they'd be able to modify enough properties on here. Let's see. I'm including a video of the past about. Oh, I'm just reading your comments, guys. Everything moves and seems to sync, but the movement. Jason, so broadly speaking, what you are working on is a category of rule engines. I used to make those in Enterprise. You end up with a condition class and an action class. Yeah, I've created something similar using like a lot of Unity events. Let's see, so broadly you can say on fire, condition, action, and then using inheritance and list of items, you can stack those rules. Yeah, if anyone's familiar with the command pattern, that's what Jason's kind of talking about here. You can record the actions and play them. Let's see, you'll have to assign the new weights and start, and Yosha, it's been a while since anything with networking, but generally speaking, if you want to play to move with the platform, it should be a child. Okay, let's see here. If we were creating, and let's actually test it out, like how far into our space shooter adventure could we get, right? So let me delete those. Let's actually create some prefabs. Okay, so the first prefab we're going to create is our spawner. And we're actually going to remove the mesh renderer, the box collider, and we'll go ahead and add that tag. All right, so here's our spawn point. It's going to have a spawner script. All right, let's just drag that into our prefabs. Okay. Let's see. So let's say we had a player here. And we're going to add our WSAD movement to that player. We can set a position for where we want the player to always start. Let's set it at like -2 on the Y, so it goes down. And then we will go ahead and create our spawn points. And maybe we should create a wireframe visual for that so that they could actually see that. I think we'll do that. But for now, let's go ahead. Let's move like -4 on the left, 5 on the top. All right, +4 on that end. All right, and then here it's going to need basically an enemy. prefab, which is this guy. We'll go ahead and rename that to enemy, drag that into our prefabs folder. We have a box collider on our enemies, mesh colliders. We have the direction to move, the speed at which we move. All right, and everything else looks good there. So let's call this spawn point A and B. And actually what we could do now is if we had multiple spawn points, we can support randomization of these spawn points. That's something that I think we could do. So if we had 2 of these, we can randomize which one's going to take control at any given time. So I think we'll do that. Let's see. Let's just get that enemy back up in here. Amount to spawn, we'll set it to 1. The frequency can be 1. I'm going to loop spawn point B. All right, so without any coding, here's essentially what we have, right? So we have these objects here coming down. We can move left and right. Now, the question is how do we support the ability to randomize this, right? So essentially what we could do is there is a concept, an easy concept could be a flyweight design where we could have a reference to all of the spawn points, which I don't know if that will work here because these are individual instance objects. We might need to create a potentially manager type function here that, because basically this spawn A and spawn B needs to know about each other. So the way we could do that is we can dynamically grab the spawner script. So we can always know how many of these spawn points are in here. And essentially one of these can override all of them. So let's say you were looking at spawn point A and you wanted to randomize between spawn positions. If you check it on spawn point A, I also want it to be checked for essentially on spawn point B. So it's like they need that shared data. The problem with this is I'm not going to be able to get it in the inspector here without a custom editor, I think. Essentially the way we could do this is these spawner scripts share a commonality. And that commonality is essentially a static variable called, let's say, bool randomize spawns. So this bool runs along all classes, and I don't know if we can serialize and check that on them. Let's see. Yeah, no, we can't. However, if we go into debug mode, we'll see that. So frequency, weird. We should see it in our debug mode. I do not see it. Hold on, let's open that up. Oh, okay, you know what, Jason, that's not a bad idea. We could, okay, yeah, so what I tend to do is have a spawner called multi-spawner. Okay, you know what, that's a great idea. Let's create potentially a multi-spawner that then can support multiple things, right? And it would take this packet essentially. I like that. Let's do that. So we have normal here. All right, so basically this is individual spawn points and will be treated as such. What we want to do now is create a multi-spawner. So let's actually add those spawn points in. This one here will create a new C# script. That's going to be a multi-spawner. And here's our multi-spawner game object. And we'll drag that on. Okay, so the purpose of the multi-spawner here is that we are going to be basically randomizing between all of those spawn points essentially. So we're going to create here an array. Stop into our namespace. All right, we're going to create a spawner array. And then we might be able to modify certain properties on these spawner points. Essentially, what we could do is override their base functionality if they are included in a multi-spawner. We'll have to see how this works. Let's go ahead here. We make it so we can add these array points. So within these spawn points, we can access them, and any data that's here, essentially, you know, we could access. So we could, for example, grab the object. We can create a getter method that's going to return the object it needs to spawn, and that could be the one. Trying to think actually how to visualize this better. So let's say we were to add point A into this and point B. So we have two different types of spawn points that we can use. The problem now is that they have their individual spawners. So I'm wondering if multi-spawner should be independent of these spawn points potentially. If you have a multi-spawner, why not just let them do a transform object where they can position it and then a game object? The challenge there is, like, what if they had multiple different game objects they wanted to spawn? Having this spawn point data, which tells us what game object they want to spawn, because spawn point A and spawn point B could have different game objects in here. What we want to be able to do is grab that data and spawn it. Hey, what's going on, Jason Harrison? Let's see here. Essentially, we could... All right, let's do that. Basically, we just need to notify each of these if they are part of a multi-spawn internally, essentially. Which means we might not want to do this in void start here. Essentially, what I want to do is we're going to relinquish control to the multi-spawner to handle it if this spawner is part of a multi thing. So here, what we can do for this is I'm going to create a public property. All right, part of multi-spawner. So here, if we're part of the multi-spawn, we basically want to eliminate doing any of this, right? We're not gonna control our individual spawns. That functionality will be handled by the multi-spawner. I'm trying to think if this is unneedingly complicating it. Because if I had those spawn points, just over the vibes. Let's see. Yeah, so we could move start altogether and do all this stuff and just like call a independent spawn method. Let me see here. Or this could just be a data class, right? Like this spawner could just hold the data for information about and then let the multi-spawner, even if it's only one spawn object, control it. And maybe we'll do that. Maybe that's the best way to do this. This multi-spawner object, well, if we do it that way, we should make it so that potentially there's only one multi-spawner in the scene so that we can access this, like potentially turn this into a singleton. Let me think, is there any reason why we would have a multi-spawner, like two of multi-spawners? I do not know, I don't think so. One multi-spawner should be able to handle all of the rule sets for every spawn in the game. So I think we'll do that. So let's do this. We're gonna have an array of spawn points for sure. And maybe they'll add themselves to a registry. Maybe we'll, Then the multi-spawn iterates the other spawners and calls spawn. Is a spawner? Yeah, we could do, okay, I see what you're saying. Multi-spawner becomes a spawner type itself. So basically this spawner becomes a base class essentially and has the instructions for spawning. Multi-spawn becomes part of that. iterates its own children and calls the other spawns. Yeah, I don't like the inception. I don't like the inception of allowing them to get down an infinite nested spawn loop. Let me see, I'm trying to think the most simplistic way to do to create this. Potentially, I do like that. So if we did, let's see here. We have our spawner, we have our prefab to spawn, the amount to spawn, we have the frequency. And then here we have whether or not we loop that, we have our frequency delay. Let's say that every spawner here trying to think if there's ever a scenario where we would have different spawn types. I don't think so. All right, you know what? We might do that. Let's try this. We might do this. I think that could work. All right, so essentially we have our spawner game object, and every spawner has information. So the spawner is going to have a prefab to spawn, the amount to spawn, how many of that object, the frequency at which we spawn them, and whether or not it's going to loop. Let's go ahead here. We're gonna go and set this to, we're gonna set these to protected so we can access them from our multi-class. And for now, we're gonna just get rid of this for a second here. Okay, and then basically a multi-spawner now can become a spawner itself. I'm going to delete this for a sec. All right, so the way this is working is essentially our multi-spawner is of type spawner, and we have all the same properties that everything else has. The reason why we can even attach it to a game object is because it inherits a spawner, which inherits mono behavior. So when we say multi-spawner is inheriting from spawner, we get the same properties here. Now, essentially on this class, we might need to create a custom editor if I want to hide all this stuff. But this multi-spawner is acting just like a spawn point essentially here. And what we could do now is we could actually put, I think like Jason was saying, we could put spawn A and B as children of this. And then we could actually loop through and call their action items, right? They all have an action to call. I don't know if we actually need this to be its own multi-spawner to do that, to be able to spawn stuff, but essentially it can have a child multi-spawners and so on. Yeah, I don't actually think we need to make this, I don't think this actually needs to be a spawner at all. I think instead it can actually just go through and loop through the spawn points and perform their actions. So what we'll do is we're going to add back here private spawn points or spawner array. Each of these spawners will have an action on it. And we'll have an IEnumerator for its routine. So here we have our action and then IEnumerator start spawn sequence. So we can still support whether or not it's looping. And then here we're going to grab all of this fun stuff. All right, we start our spawn sequence. And then now we just need to call this action, right? So within these here, we can basically loop through and call all the actions for the multi-spawner. So we loop through the spawns, and then we can say spawn.action. So now they can all behave independently. So we can have spawn point A amount to spawn. Let's set it to 5. The frequency, let's set it to like 0.5. Spawn point B, and we'll just loop, and spawn point A will not be looped. Okay. So what we can do now, I don't actually need to child these at all. Let's go ahead here. And we have a script error potentially. Let's see. I'm doing here from auto behavior again. All right, we'll go ahead and put spawn point A, spawn point B. We'll save that out. So we have 2 different spawns here, and each one should now be triggered to do its action from this guy. So this allows you to essentially individually configure a spawn point to behave how you want it to, and then you can actually go through in here, you can and then set it up into in this queue. The reason why I want to do it this way is because now we can actually individually decide. The multi-spawner can actually take control and override a lot of things in here. So if we wanted to support the ability for random spawns, so let's do a bool here. So random bool, private bool random between spawns. And actually, I'm trying to think if that will work. That assumes it's all the same game object. I think it has to stay independent. In order for this to work, it would need a more intricate rule set for if the spawner has different game objects. Like, what are we, and the frequency could be different, right? Like, do they share the frequency at the random spawn point? The purpose of this was to randomize the position of the objects. However, the fact that the objects could be different, you might not want to be randomized. So really, all we did here was just create a container that calls the appropriate spawn things. I don't know if that's a good idea or not. Essentially, what we could do now is child these so that it's just more organized. But essentially, all this script is responsible for is just queuing the spawner scripts, which we're doing on their own. Yeah, I don't know how far you can take the randomization here without assuming too much from the end user. Let's say we got our multi-spawn. Because now essentially all we did was kill spawn point B to work on its own. So if we turn this off, these individual spawners will no longer work. So I'm trying to think how we can best create that. I'm gonna think about that. We'll come back to that one. Let's go ahead here. Let me update. We got to revert some of this stuff here. So now we have our action. Essentially, this can be our start function on the spawner, essentially. And it's going to start coroutine spawn sequence. We're going to do all the spawning. If it's looping, it's just going to loop. Hey, what's going on, speaker? Okay, let's see here. And hang on, just got a Discord message. Okay. All right, cool. So let's see here. Yeah, we'll come back and take a look at some multi-spawning when I can think of how we want this, how we want to be able to support potentially more advanced spawning. Let me delete that. It's no longer going to be used. Spawn point A. Okay, so here, I can only imagine a multi-spawner would be useful if all you wanted to do was randomize between all your spawn points. But then then that's literally what it would do. I don't think it has to interact with the existing spawns. It would be individual spawn points. So a multi-spawner would be treated as if it was its own spawn game object. So you choose the game object, the frequency to spawn, and the positions to randomize against. And I think that's potentially a better implementation of this. So here we have point A and point B, which are individual spawn points that can be configured. We could now create a proper multi-spawner using this. So let's say here, a multi-spawner has all the same properties of this, and then it just has position data though. So only thing that's missing from spawn point B and spawn point A is position data. It's assuming the positions that you set here. So I think that's the way we could do this. Okay, all right, I think it's making more sense now. Let's go ahead and try that actually. So here, let's add that multi-spawner back in. Whoops, and give me 1 second, guys. Hold on, I'm getting a phone call here. Hang on. Hang on. Okay, let's see. Sorry about that. I had a phone call. We are back. Let's go ahead here. Let's go ahead and finish up this multi-spawner. Let's make it to where you can basically assign potentially random points. So the multi-spawner will inherit from spawner, so we get all those properties. But it's going to be its own unique property of it. So instead of using the traditional spawner that's going to instantiate, we're not going to use basically its implementation of it. We want to update the position that's going to have. So we need to basically record spawn points, and these are just going to be game object transforms essentially. All right, and then within the base class, let's create an overridable method here. So right now we basically say, hey, the spawner itself is basically going to start a coroutine that says start spawn sequence, enumerator start respawn sequence. So what we want to do is potentially create something where we can pass in a parameter here for a position data. And if no position data is passed in, we're going to use our transform.position, or we're going to use what our multi-spawner is wanting to use. All right, so let's see how we can actually do this. Let's Let's see. Here's our start spawn sequence. And let's take this code. Let me see how to do this. The coroutine is messing me up here. And let's just look at this object real quickly. Here's our multi. Here we go. So let's say that we wanted to spawn an enemy. The amount to spawn is going to be 5. The frequency is 1. We'll loop it. And then the spawn point array here. So we need to update that. So here we have our transforms. And let's just use for now the position data of those two other objects. So spawn point B and A. We're going to remove that. We're just going to disable the component for now. I just want that position data off them. So spawn point B, spawn point A. And then what we could do is create our own, we technically have, we do have a game object to spawn here. So I have all those properties. So essentially within here, we could have our own void start. But the problem is we're going to be duplicating code here. We could have our own IEnumerator to do all this fun stuff. I just don't know if that's what we want to do. And I don't think I can call the base.start, can I? So if I do base.start here, it's basically just going to, it's just going to instantiate at the current game object's position, which is what's throwing me off here. We need this to be the multi-spawner's position. Really, the only purpose of inheriting from spawner is just so that I don't have to duplicate this data right here. What we should figure out how to do though is more modularly make this a generic spawner script that has an action that can be overridable with a position, essentially, is what I would like to do. But I'm blanking on how to approach that right now. So until it comes to me, we're going to, let's get this loop working. So here, this guy's start method. And we will do all of that stuff. So for a second here, we're going to copy and paste what we had. Put it back. See here, we have our frequency delay. We turn that off. It's just for a second here. I just got to prototype this out, get it working so I can visualize what I'm trying to do here. We're going to do wait for seconds. We're going to do the frequency. Okay. Now here is where we actually randomize the spawns. So instead of spawning at our transform.position, we want to basically choose between the spawn points, essentially, right? So here, we need to randomize what index we want to use. So here, our index is going to equal random.range between 0 and the amount of spawn points that we have. So if we have 2, it's going to give us between 0 and 1. And then instead of just the transform.position, which is the game object of the multi-spawner, we need to say spawn points sub index, which is random, dot transform, dot position. And I think we can actually just do dot position here. There we go. All right, let's save that. Here, let's put this back into a namespace here. All right, let's see here. So we got our multi-spawner. We're gonna go ahead and do this. All right, so now these two are independent. We're using inheritance to just get this core data. But now the multi-spawner should spawn randomly on loop between these 2 points here. All right, so that seems to be working pretty well. Right now, all these game objects are doing are being used for their position data. We don't actually need that component at all. There might be a more intricate thing we come back to on this, but for now, I think this covers the point of being able to create like a spawn of one type of object randomly amongst different points is essentially what we want to be able to do. Let's see here. In the base class, we might be able to, let's see if we can optimize this. I want to get rid of this this new wait for seconds here. So in the actual base class of this, if we go to our spawner, let's see here. We have frequency delay equals new wait for seconds. And instead of doing it there, let's initialize that in the base init, which is going to be this start method here. So frequency delay equals that, because then we can actually, we can grab that multi-spawner here from the base. Let me see here. I don't know if we're going to have an execution issue. We might have a null reference that happen here, but we'll see. Yield return. And we'll grab that frequency. And here we use awake actually for this. So awake, we set our frequency delay. That's going to be our init method. And we could create a whole overridable thing, but we're not gonna do that. So void awake, we do that, and then in void start, we'll start that spawn sequence for these guys. This way, the multi-spawner, it's guaranteed that it's not going to be null when we get that frequency. Okay. So now it's using the frequency here, the amount to spawn, and we should be good. Bro, just give any idea for making realistic car driving games. I have no idea. Go play Grand Theft Auto, I guess, or Forza, right? Learn from that. Dude, speaker, that's awesome. All right, so guys, the whole purpose of this stream, we're creating these interactable components, these little packets that we can attach onto game objects to create interactivity with Unity for someone who's never used Unity before. And they might want to be able to use these packets to create a simple concept game. So far we got a move, we have a multi-spawner, a set position script, a spawner script, an update color based on a key press, and a WSAD movement control. What are some additional packets that we could create here? Because right now, if we run this, the way that I'm visualizing this is how far into creating a space shooter could you get without writing any code? So we don't have the ability to shoot anything. We don't have a shoot mechanic. We could, I'm curious if we could create using a spawner, how could that, could the spawner be used to create a bullet prefab, right, at the position essentially. So this spawner point has rules attached to it. And I broke the prefabs on these. So let's go ahead here, we're gonna apply all, we're gonna fix the prefabs in a second here. Okay. All right, so our multi-spawner here is missing some points. So let's go ahead here. Let's add those back. Let's just get our spawns in here. All right, so we got 3 spawn positions. All right, and let's go ahead here. Let's put those into our spawns. All right, so we got our spawn, and actually, hold on, I want to zero that game object out. Okay, so we're inside of our spawn points here. Let's see how we can use this generic spawner, this spawn point, to create a spawn when a key is pressed, right? So support the ability for example, the space key. And then maybe we'll create a custom editor to draw a display based on that. So let's remove the WSADs, positions. All of these actually don't need box colliders. We'll keep the mesh renderer, just visualize it, but we'll keep them disabled. Okay, so these are our spawn points. And all we have to do now is just add our script onto them, the spawner. Okay, cool. Here, I just want to actually fix that prefab of it. Alrighty. And here we're going to delete these two. I believe the multi-spawn. All right, we're just gonna use the multi-spawner to spawn these. All right, so the question now is, if I just use the generic spawner, right? So I'm actually gonna delete the multi-spawner. If I just had a spawn point here, just like that. All right, so we got this spawn point, right? And we wanna basically spawn an enemy. But what I actually wanna do is create a bullet, right? So on our player here, if I were to create a 3D object to represent our gun, let's go ahead and move that up. Let's shrink it down. All right, so here, if I wanted to create the ability for us to shoot out of this, I would assume that I could use a spawner component, right? So here we're gonna add a spawner component, and we'll create what that prefab looks like. Right, so let's create our bullet. And let's proportion it down to how it should be. Okay, so let's say we wanted to spawn this object, right? And then essentially when we spawn it, we're gonna have a move script on it. The direction is going to go up. It's gonna have a speed of like 10. So far we're being able to plug and play this interaction in Unity, which is the goal. So now the question is, how do I make it so that this spawner will spawn an object when I hit the space key? All right, and that's what I want to support next. So here, let's go ahead here. We have our bullet. Let's prefab that. Remove it from the scene. Look on our spawn point. Let's actually configure our gun here. So our gun is going to take a bullet. The amount to spawn is 1. The frequency will be 1. And we don't want it to loop because we want this to be based on a key input. So here, what we're going to do, what I would like to do is create a drop-down menu, right? So if you were to check something that's like, in order to do this, we have to create a custom editor. But essentially, what you could do is say require key input. And if they check that, then it opens up a selection for you to create a key input. The reason why you have to use a custom editor for that is because not every spawn is going to require key input, so it doesn't really make sense to always have it visible. But just for functionality purposes, here's what we need to do. So here we're essentially going to create a protected key code. And we're going to call it key press. All right, so here, key press is currently set to none, and I want to make it a required thing, right? We need to know if it's required. So the program doesn't know if it's required, so we need to decide private bool We'll call it key press required. And that's going to be, by default, it's not required, which means you, as the end user, need to check that. Let's go back into Unity here. So here we can see on our gun, we have key press required. I'm going to check that to yes. The key is going to be space. All right, we're going to select the space key. And then now we need to check, right? So we need to ignore some rules here. So for example, in void start, we're not going to start the spawn sequence if we're doing a turn key, if we require key, right? So here, if required key, so if key press required is false, then we'll go ahead and do this behavior as normal. And then I want to make sure that we actually call into our base.start. Possibly. Let me check something here actually. I don't want to do that. Because now I'm trying to think on the multi-spawner how that's going to mess that up here, because this guy's still going to run on the multi-spawner. But the multi-spawner is not related to this, so it should be okay actually. Yeah, I think we should be okay there. All right, so here we have our void start. So if key press required is false, then we start coroutine. We're going to start that spawn rate sequence. Otherwise, it's now going to just wait for us to do input. So here inside the spawner, we will actually have an update method checking for that input. So if input get key down, we'll go ahead and do our press key. So if you actually hit that key, whatever it may be, for us, it's going to be space. Then we are going to process the instantiate code. Let's see. Something I want to check real quickly. Can you override coroutines? I want to get rid of the duplicate code, and we can do that by overriding this. I don't know if you can actually do that. Private virtual, oh, I guess you could, or maybe not. Let's see, can you show us where you... Okay, they're showing that you can override an IE enumerator. So, all right, good deal. Well, that will be an optimization that we'll look at towards the end here. All right, cool. Let's see here. So if input that get key down, key press, instantiate prefab to spawn, transform.position, quaternity identity. I think that's it. And it's going to spawn that prefab. It's going to automatically have its rules attached, and we should be okay. The thing here, though, is that there's no delay. So we want to incorporate that frequency delay, right? So we still set the frequency of how frequently we can spawn this. So we need to make sure we incorporate that. So here, if you hit the key press, and we need to create a cooldown system, essentially. So we already have our frequency. What we need is another variable for the cooldown system. So here we need to know, hey, can next spawn? All right, so there we go. We got next spawn, and then inside of here, if input.get key down, and we'll go ahead and say next spawn is greater than time. And actually, I'm sorry, next spawn is less than time.time. So if next spawn, which is -1, is less than how long the game has been running, which is going to be 0, we're going to instantiate. And then I'm going to set next spawn equal to time.time plus the frequency delay that we have. All right, and that's going to make it so that we can only actually shoot every 1 second. All right, so we got our player. We can set the position of the player, the movement keys. The gun has a spawner script. It's got bullet, amount to spawn, the frequency, whether or not it should loop. I don't know what happens if you press that loop. I think that's going to break something. I don't know if it's even going to work because key press required is checked, and that's where custom editors come in handy. When we have a custom editor, if key press required, I can redraw this so that only the properties that will work will be drawn here. So I think we'll take a look at doing that. We're going to take a look at doing that possibly right after this. So here, key press required, key press is space. Let's go ahead and test it out. We can basically go ahead and move around, and we have an object shooting out. All right, so without any coding, we can get to this point. And if we had our spawner working, objects would be coming down, right? Okay, so let's see here. Let's take a look at doing an editor script. So in order to do an editor script, we have to have a folder for an editor. And what I want to do, I want to create an editor to customize the drawing based on this parameter. So if you say key press required, this view is going to completely change. Or we can even ask like preliminary questions, like what kind of spawner is this? You know, is this going to be a spawner to shoot things, a spawner to spawn objects? And based on that information, we can display whatever we want. All right, hang on, my chair is squeaking, it's driving me nuts. Okay, so inside of, let's open this up. We're gonna create a spawner editor. Spawner editor, yeah. All right, give me 1 second here. Here's our spawner. All right, give me 1 sec, guys. All right, so let's take a look at this. All right, so I basically want to override the drawing of that editor so that we can customize it. So when you check that bool, we remove the properties that are irrelevant to it. All right, so the way we can do this, we have to inherit from editor instead of mono behavior. The next thing here, we need to make sure Unity editor is included, which it automatically is. All right, and then there is a method here called public override void on inspector GUI. And this method here implements this function to make a custom inspector. And if we don't call base, it's going to be completely blank. This is gonna call the default stuff, and then we can add in our own stuff that we want. All right, so, and then here we need, hang on. Let me add this into our GameDevHQ.editor namespace. Weird. It's not like that. Okay, that's fine. All right, so spawn editor, public override void on inspector GUI. I need to tell it to override the inspector, so I believe we need the custom editor type of, and this is going to be of type spawner. Okay, so if we actually just run this right now, we should see 0 change, but where it's gonna change is when I delete that line of the base. And then I control how it draws. So right now, our spawner looks totally normal, right? Well, watch what happens when we do this. I'm gonna remove that base call, and I think we're gonna lose all properties. At least we should. And if that doesn't work, we'll have to pull up the documentation. And we did. You can see here that spawner is blank. There's no properties now. I could put whatever I want in there, right? So I could actually, I could display, for example, I could display like editor GUI layout dot I don't know how to do. I forgot how to do the property fields on this. We'll have to look this up in a second here, but let's just do like dot label. My custom inspector for spawner. All right, and there we go. My custom inspector for spawner. So we're overriding what the initial one was. So what I want to do is I kind of want to get back to a default state and just wait for, is key press going to be required? And if key press is required, it's going to change a lot of the rules. So the first thing we need to do is we need to get all the properties that we want to display. Now, when you're working with custom editors, there is something in here called a serialized property that's going to let us do that. So this class doesn't actually know about the spawner. It's just overriding that spawner in the inspector here. I want to grab the properties in it. So in order to do that, Unity will automatically, I believe it's done through what's called reflection. It can read potentially what's in that. I'm not 100% sure how this works underneath the hood. However, we can do serialized property. And this is going to, let me see if it gives us a reference to this. Serialized property and serialized object are classes for editing properties on objects in a completely generic way that automatically handles, undoes, multi-object editing, and prefab overrides. It's basically the ability for us to get a reference to the prefab to spawn, and it will allow us to do things like Control Z, undo. It's basically like Unity magic, is the best way I can define it. But essentially here, what we're gonna do is serialized property. We're gonna have prefab to spawn. Once it now knows about that prefab to spawn, I can actually draw that. So here, we're gonna say, for example, I'm gonna say prefab to spawn is gonna be equal to a serialized object. And if we read that one, it says a serialized object representing the object being inspected. And we are going to find a property. And I believe this is the part that may be using reflection to do this. But essentially what we're going to put in here is the variable name. So the property is the variable name that we're looking to reference, and it's going to pull all of its data. It's going to know that, hey, this is a game object type, and it's just going to magically work. So here, if I type like prefab to spawn, I think is the variable name, we have to confirm that this matches this. You'll see here prefab to spawn is the variable name. So in our spawn editor here, if we go back to Unity, we should actually be able to now assign a game object. So in our spawn point, which I cannot do, and I believe I have to call an update method. I think I forgot that. We have on inspector. Oh, you know what? Hold on. I think we need an on enable method actually. Hold on. If we go to void on enable, it's been a while since I've created custom editors. Here, let's add this to here. So we initialize that. Then we need to call serialized object update. .update. Update serialized object representations. Okay, I believe this is the line that's gonna make it so that this actually displays. The other part of it is I actually need to draw it, right? So one, we need to tell Unity, hey, go ahead and grab the latest information that's here. But then two, we actually have to draw this. So we're gonna do that using an editor GUI layout dot property field. And a property field is going to allow us to make that field where you can drag in the game object. And you'll see here that it's asking for the prefab to spawn, which again, if we look, what is the prefab to spawn variable in this class? It is a serialized property. It's going to automatically interpret that I want a game object because I specify that I want a game object over here. So now let's hop into Unity. And we should see on our spawn, on our gun, we now have a prefab to spawn. And it automatically populated the bullet because that's what it can remember. So now I could change that out. I could put enemy in here, and you'll see that nothing is happening when I do that, which is a problem. Let's go ahead here and make sure that we need to call another method. I believe there's a modified method. Let me see here. When you make a change in Unity, it does not update until you like set an object to what's called being dirty, I believe. So let's go over here. We serialize update, and then the last thing we want to do before the next frame, by the way, this is running at like, I don't even know, 120 frames per second or something like that. It's very, very fast. I think we want to do serialize object serialized object dot apply. There you go. Thank you. Apply modified properties. Boom. All right, so it should now update to the object that I actually put in there. Interaction, like picking up upgrades and boosts. Yeah, absolutely. We'll create a generic spawn type thing too, like collect like a generic collectible. That's coming up. All right, cool. So check this out. So if we look at our gun, we now have a bullet. I should be able to swap in an enemy, and now it's updating to the enemy. If I put the bullet back, we now have a functioning custom editor here. Let's go ahead and get our base properties back that we want, and we can actually customize how we draw all this stuff. So let's open up our spawn editor here. Diego, do I think a procedural map generator can be considered an IA? I'm not sure what an IA is. Are you AI? I'm not sure what an IA is. What's an IA? Or yeah, what's an IA? Okay, here we go. So we know that we need our prefab to spawn. I know I need the amount that we want to spawn, right? So we need to go back up here and we need to recreate that variable. So serialized property, and this one is going to be amount. And I believe we called this amount to spawn. This variable actually doesn't matter, by the way. This could be whatever. This is just how I want to display it in the inspector. All right, so amount to spawn. And then here on enable, we need to say amount to spawn is equal to a serialized object field dot find property and I don't know why I can't do lowercase serialized. All right, find property, and then the property is how did I name it in the spawner? I named it underscore amount to spawn. So it helps if you actually keep these things consistent, because then you don't have to keep going back and forth. So here, we're looking for that property, amount to spawn. Inside of our inspector here, we're now going to draw it. So I'm going to say, hey, editor GUI layout, dot property field, amount to spawn. All right, and again, let's just go back into Unity here, and we'll see that this now updates properly. We should be able to have a float or int field here, and we do. So spawner, prefab to spawn, amount to spawn. Let's see here. Or artificial intelligence, we'll see yet to decide. Ha, cool. Yeah, Bark, you should definitely book a call with us to chat about what you're thinking in terms of a career as a software engineer. All right, let's see here. What else do we need to do? So we have our frequency, we have the loop settings, we have the key press settings and the key press. So let's get all the variables back, right? Let's just get the base variables back, and maybe let's organize this in a way like base data essentially, right? So here, let's do editor GUI layout dot. Is there like a title, or is that a label? I guess a label field, and we're gonna call this base data. So we have base data, right? Editor GUI layout label field base data, and then I'm gonna add editor GUI dot, there's so many things you can do on this stuff. Editor GUI layout dot space, and makes a small space between the previous controls. Sweet. And let's add like 5 pixels of space. I believe this is in pixels. So if we go to our gun, you'll see here that we actually have base data, and it says prefab to spawn, amount to spawn. Serialized property, do we want to loop? And does that change anything if we loop? It does not. Only the key press required do I want to control how this draws, right? So base data, let's go ahead and get frequency and loop in here. All right, so again, if you do this in a nice, slow, easy way, and you keep it consynced, it's pretty easy to get to grasp how this all works. This is our frequency. Then we have our frequency is equal to a new serialized object here. find the property from the spawner class called frequency. It's going to automatically interpret that it's a float property. And then we need to draw it. So editor GUI layout dot property field, and we're going to do frequency. All right, so last one here is the loop, and then we get into the custom drawing of the key press. All right, so here again, serialized property. Let's get into a loop. We know that it's going to be a bool, so this this process here, the loop value is going to be equal to the serialized object property. Based on that, it's going to automatically know that this is a bool. And then again, we will draw it. So editor GUI layout dot property field. All right, editor GUI layout dot property field and loop. All right, cool. So now we have all of our base stuff. So let's just go into Unity. Let's select our gun here. And if we look at the spawn point too, this one should also have it, right? So enemy 0 frequency loop, I can check it here and notice it doesn't affect it here. It's an individual instance. So I can uncheck loop, frequency, amount, our bullet. And let's remove that spawn point. All right, so now I want to get into the key press part, right? So here's our base data, and I want to like center this and make it bold. But I don't know how to do that. Let me see here. How can I add a label and center? Here, let's look at editor GUI layout bold text title. There we go. GUI layout bold text. Let's see, editor GUI layout that label field inspector, editor styles bold. Boom. That's what we're looking for. So here, spawner editor, we can go into our base data, and we should have a editor layout. And you'll see here that there's GUI layout options essentially. And if we look, I want to bring that up. Hold on. I just blanked on what that syntax was. What was it? It was okay. GUI layouts. Editor styles is what it is. Is that a default class in Unity? I've never used that one. If we look here, we can say editor styles maybe? Editor styles. Oh, we can. Sweet. Bold label. Style for bold label. Yeah, let's do that. All right, and if we look at our gun, there we go. We got base data, and then I might be able to center that. I'm not 100% sure how, but I would like to. And that's the benefit of like these inspectors. These inspectors will let you literally center this data. So let's go into our code here and see how we can do that. So here's our label field, which takes up the GUI layout. And that might be what needs to change. So editor GUI layout takes up the entire width of this. What it lets us do is it expands it. So if I drag this, you'll notice that things look correct. That's because we're using editor GUI layout and not editor GUI. If you do GUI, you actually have to position things based on pixel. So I want this, as I stretch, I want it to basically always stay in the center area, right? So let's look at our spawner editor here. I might be able to add another parameter here. Let's see, editor GUI styles. What else do we have here? Label 2 style params options. I think we need to create additional options of this. I don't know if it's gonna let me just do that. But how do I center? Let's see. Here, begin horizontal, end horizontal. Editor GUI layout button 1, layout, blah, blah, blah. If someone can tell me how I can center my labels. Okay, so we create a style, new GUI style, skin.label, alignment. And then here you pass in that style. Okay, so they're creating a style essentially, the new GUI style, which I really want to avoid. I don't want to actually create that because I'm going to go down a rabbit hole on that. Text anchor alignment. I don't know if you can just modify alignment. Let me see. You know what? Actually, let me see here. There is something, I just saw this. Editor GUI layout dot, let's do a begin horizontal. And a GUI layout dot, what does this flexible space do? Insert a flexible space element. Not sure. Let me see here. That might automatically center this for us, possibly. Let's add our label. So there's our label. And then here we're going to add a GUI layout dot flexible space element again, and then GUI layout dot end horizontal. And there we go. All right, so that is how we can get that's how we can get that centered. It's basically adding. It looks like it's adding a space. It looks like it's adding a space on both sides of this. So I actually don't like particularly how that looks. So we're gonna go ahead and remove that. But pretty cool to discover flexible space here. All right, let's drop that out. All right, cool. So we got our update. Begin horizontal label field based data. We don't need this anymore. Keep the space there. So now we have all of our properties drawing. The only one that's not drawing now is the what's it called? Our key press required. When we do key press required, that's when I want to display the option. I want to display the option for key press, the key code, but then also I want to hide the concept of looping potentially, or maybe it could still loop if it's a key press. I want to hide. Actually, I don't know if we need to hide anything. I think we're just going to end up showing something. We'll see. But essentially here, let's create our serialized property. And let's do a serialized property. Let's get key press required. Unity will magically know that that's going to be a bool through this serialized object here. All right, key press required, and then let's go ahead and draw that. So right here, for now, we're just going to draw it here, but we are going to have to check for a change. For example, when the user clicks it, we're going to modify the UI, and I'll show you how we do that. But for now, we're going to do editor GUI layout dot property field, and this is for key code required. All right, so we're grabbing this, which is set to that property. And if we go back into Unity here, we should have our final one here. All right, so here's what I want to do. We have an object null here because one of the parameters is named incorrectly. If we look here, it said key press required. We need to go to our spawner and look at that bool. Let's just copy that. Put that here. And then also make sure that's correct there. Okay, let's save it and let's just it out. All right, cool. So here's our gun. Key press required. Now what I want to do is when I check that, I want to have the display open up for a key press. And when I uncheck it, I want to remove that display. So this is where we can actually create logic now while we're actually drawing this inspector. So to do this, it's actually pretty easy. Always the last thing we want to do is apply modified properties. But in here, there is something to check for a change. And I believe it is editor GUI dot, there's like a change here. Here we go, begin change check. Starts a new code block to check for GUI changes. So it's gonna identify like, hey, something changed here. And what I wanna do is we're going to toggle between that bool property here. And let me see. So here's our begin change check. And then, how can we do this? We're going to get key press required dot bool value of the Boolean property. Okay, and then good, it's helping me to figure this out. Auto toggle, and what is that gonna do? Make a toggle. Okay, sweet. And we're going to give it just a message here. We're going to call required key press. And then this should be the key press value. Key press required dot bool value. All right, so basically we're toggling on and off the check. We're checking for the change of you checking and unchecking this value. And let's see here. Then we have that. All right, and then now all we're gonna do is actually draw that based on an if statement. So we can actually put logic in here. So here, if the actual key press value, if key press required dot bool value is equal to true, right? So you toggle it to true, then we're going to display our enum or our selection, our enum value index, right? So for the key codes. So the key code is just an enum selection dropdown. That's when we want to display. So we'll have to look at how to do that. So display enum here. All right. All right, and then I think we should be okay. So here, key press bool value. I want to go ahead and just debug.log that this is working. And then we'll go ahead and display the enum. So debug.log. Show key press selection. All right, let's see here. We have our spawner. Okay, here we go. So we have key press required and required key press. All right, so here we go. So that's actually gonna handle our toggle, right? So if I check this one, show key press selection was pressed, and it actually is mimicking these. You can see here that it's drawing it twice. And I believe I am doing that by mistake. So if we open up our spawner editor, I am doing that right here. I don't believe we actually need to because I'm drawing it right here. So I was drawing it twice. Let's go ahead and go back to it. Select our gun. And here we go. Required key press is false. It was true by default for some reason. Let me see here. All right, so here we go. Required key press is now true. Show key press selection. If I turn it off, it stops executing. All right, so everything is working how we want it to. Let's go ahead and draw the drop down based on this checkbox being true. So let's open up our spawn editor. All right, and instead of this is actually pretty easy to do. The first thing here is we need to actually get the key press serialized property. All right, so nothing changes here. So serialized property, let's grab the enum. So this is going to be the key press. And then here we still have to do all of this fun stuff. This is how Unity intelligently knows that it is an enum of type keycode. So we'll do keypress, serialized object, dot find that property. Let's grab the keypress and just make sure that that matches the variable name here, which it does, keypress. Cool. All right, and then now we get to the drawing, right? So we're gonna draw it only if we are requiring a key press. And to do that, we basically just say, hey, key press. And there is an enum value index here. And let's see here. So enum index of an enum property, we're gonna use that. And that's gonna equal the key code selection. So here, editor GUI layout, dot enum. So this is going to actually draw the enum for us. And then we're gonna probably have to do some cast operations here. But we're gonna do an enum popup. So enum popup. And this is literally how Unity is drawing the enums for us, right? So like if I were to go back and do the base and you have a selection drop down of things, like this is what's happening underneath the hood. Unity is doing this for you. We're gonna create an enum popup. We're gonna call it keypress. And then we have to do a keypress.enum value index, I believe, on this. Option label, and let's go back and look at, it should be keypress.enum value index. And we might have to do some cast here, but let's see, this should hopefully work. And we're definitely gonna have to do some cast. Cannot convert from int to Unity Engine options. That's because the key code, we need to go convert it to a key code. Keypress, key code, keypress.enum value index. That actually should be okay. I think I'm missing one more cast here. Cannot specify type system enum to int. And that is because we are missing our int key code here as well. So this actually needs a double cast. This needs to go to a key code, and then that key code needs to ultimately become an int type. All right, we got our key press, sweet. All right, so let's go ahead and test this out. This should automatically display for us now our dropdown. So here, key press is set to nothing. If I select space, here we go, and now it's using the space key. So, and if I stop checking that, it goes away. So required key press is true. Our dropdown comes back. It automatically sees that, hey, it's a space key because that's what it saved. The reason why it saves that information is because we're doing that apply modified properties, but also because we're using that serialized object, which is handling all of the undo actions for us. All right, so by default, you know how it was kind of showing nothing? I'd like it to actually display potentially none. The way we do that is by actually setting it to none. So here, keypress required.bool value equals true. I might be able to check, I might be able to just automatically set it, right? Like in here, we might be able to say something that's like, if keypress .enum value index, and I believe that's an int, right? I don't know what this index actually returns. Let's find out why it showed the way it did. It might be a -1, and if it is, it's easy to detect. Let's do keypress.enum value index. All right, let's find out which number that is. Whoops, I don't have to play. Let's go ahead here. Oh, you need lagging. All right, on our gun here, we have keypress none, which is just 0. I'm gonna go ahead and let's delete that script and re-add it. So here's our spawner. We're gonna put our spawner on here. The game object to spawn is the bullet. The amount to spawn is 1. The frequency at which we spawn it is 1. It's not going to loop. Required key press was automatically true, which I don't like. I'm not sure how that happened. But it is saying none, and it looks like it's okay. Now it's actually just working key press none, but I think it's because I set it and it's saving that information. Required key press. If I turn that to false, it looks like it's saving that data to be default, which is interesting. I want to make sure that it doesn't do that. So on enable, we can actually set that value. So just like we did it here where key press required.bool value, we can do key press required.bool value. I can get and set that value. And by default, it's going to be false. So anytime we load, and actually I don't know if that's going to happen on the initial time of this. We'll have to see. Every time we refresh it, if it goes away. So I'm going to go back off it, go back to the gun. Okay, good. It's still there. So if we remove that component, let's add it back. Go back to the spawner. Okay, there we go. Required key press is being checked by default. Let's see. Why is that happening? I might need to create an actual bool to override that. Let's see here. With this change, key press required.bool value equals false. Check for change, begin change check. I don't know if I need to do an end change check here. It's possible I might. I wonder if that's messing something up here. Here, let's check for an end change check. We can actually just say if like editor GUI layout dot end change check. Man. By the way, guys, in case you're wondering how I remember a lot of this stuff, when I worked for American Gaming Systems, I used to do a ton of custom editor stuff. So, and Firebase is completely built using stuff like this. So, if you look at the documentation for editor scripting in Unity, there's so many different things you can do. Oftentimes, it's literally just looking through all of the different selections we have here. But there is something for editor GUI end change check. Here we go. Okay, this ends a code block and checks for any GUI changes. Okay. End change checks, and let's serialize object dot apply modified properties. I think it needs to like be enforced that, hey, you're done, let's modify the properties. So let's go ahead here. Okay, so that is now set to false. And if we come back to it on reload, it's still false. But if we were to reset that script, what's it going to be? So let's just go to reset. Required key press. Why are you set to true? And it's not doing anything over here, which is very annoying. Let's remove that. If we look here, we basically say begin change check, key press required.bool value. We are drawing it here. Key press.required the bool value. And then here, if it's true, we get the index. We draw the enum. On change check of the enum, we are applying the modified properties. It's end change check that is a Boolean return if it's got the change. Ends a code block, checks for any GUI changes. Yeah, it should. This should be called here. So if editor GUI.end change check, that should be returning true automatically here as soon as I adjust, as soon as I click that element. Let's see. I'm a little stumped here. I don't see why that is happening. Check for change, begin change check. We modify the bool press. It is set to false. If the key press bool value is true, then we draw the enum. If the editor change, check. Interesting. It's drawing properly. I just don't know why it's deciding to hard code that check there. Required key press. And if I save Unity, let's delete that script, re-add it back. Weird, why is that true? Required key press. Huh, something so simple. Let's go into our editor. Editor GUI label field. I can't remember. I think on enable, I'm pretty sure this is like on an instance of this thing. I think this is only called one time when everything is like initialized. I'm pretty sure we should have been able to just say, hey, key press required. Yeah, value of the Boolean property. I don't know why I can't do that. Key press dot required equals false. And then let's do a serialized object dot update right here before onInspector GUI does. And let's also apply the properties, right? So serialized object dot apply modified properties. Just like save it. It's like, hey, go off. Nope. Wow. What is causing you to go true so hard? Hey, what's up, Dulo? We are creating interactable components so that people who have never used Unity can experience interaction. I'd like it to go as far as being able to create like simple games with it, basically providing you a bunch of plug-and-play packets that you can just drag onto game objects. But running into an issue here on why this bool is set to true. If I wanted it to be true by default, then it just works and everything is dandy, but I really want that off. The question is, why is that off? Let's try something here. I'm going to do a private bool init. And clearly this is doing nothing, which I'm not sure why. But what I want to do is we have this init method now. And if key press required dot bool value equals true, and our init is equal to false, and our init is actually true, so like we've initialized this editor, then we draw. All right, let's see if we can prevent it from drawing here, because init is now false, right? That's a local variable to the editor. It's not true. If we go ahead and reset that component, super annoying. All right, put it on the gun. And required key press is true, but we can't see anything. All right, so interesting. So this bool, for some reason, just wants to be true. And I wonder if we go to our spawner. Oh my goodness! Look at this, guys. Key press required is true by default. Ugh, that's what's causing it. All right, let's go ahead, set that to false. We go to our spawn editor, and everything else should be okay. I don't know if we need this, but we'll keep it. I think it's best practice to check for those changes immediately and then apply modified properties. If we go up here, I'm gonna delete my false thing here. We don't need that, the init. And let's go back down to where we draw and remove the init. And it should work how we expect it to. All right, let's see here. Cool. All right, so let's go ahead. Let's remove this component. Let's re-add our spawner to the gun. The game object is going to be a bullet. The amount to spawn is 1. The frequency is 1. We're not going to loop it. We are going to require a key press, and we're going to set it to space. Sweet. All right, and now I don't really care for the base data thing since we're not doing anything fancy here. So I'm going to delete that, but it is working how we want it to, so very exciting. All right, cool. So we got a custom editor for our spawner to only draw the input selection when it's required. All right, sweet. And then if we test it out, everything should still work. So key press is required. I hit the space key. And if we go to our player, let me make sure that was here. Okay, let's test it out. All right, we can move around. If I hit the space key, of course, nothing is happening, which is problematic. The question now is, why not? So it is looking for that space key. We should have inside of our spawner, we have our update method, checking for that key press, which means it doesn't fully know what this is. So what I want to do is when we run the game, what does it think our key press is? It might potentially think that the key press is none, so something's not updating. So let's debug.log that value. So on awake, which is right when we hit play, it already has the key press assigned. Let's find out what it is. And we're going to access the underscore key press dot toString. And hopefully that gives me the enum name. All right, here we go. Let's test that out. If we look at our gun, key press space, if we hit play, what does it think it is? Okay, and you can see here, the key press required is alpha 9. Actually, not sure which that is. Is that, what is that, F9? Ooh, nope. I'm not sure what the heck that did. Recording play mode has started. I'm not sure what that is. Okay, interesting. So it's actually not giving us, what we want. Why not? It's giving us one of these alpha number 9s. I think that's the keyboard or the numpad. Is that what that is? Yeah, the number 9 does not want to work. Oh, there we go. All right, good deal. Interesting. So it is somehow defaulting to 9, which could be because of our cast here. Let's see, Jason asked, out of curiosity, why are we using a custom enum drawer and not just drawing it with a property field? I wasn't sure that it can be drawn actually with a property field. Can it? Will that work if we do that? Let's try that. Let's go to, I don't know if it can support that, the property fields. Can they do enums? Let's see. That would make it a lot easier potentially. So if we do true, editor GUI layout dot property field, and let's do key press. Yeah, that might save a lot of this headache right here, because I assume something on this int cast is messing it up. But let's go ahead and see. Oh, so much easier. Sweet. All right, here's our gun. Let's go to our space. We'll save it. Let's test it out. All right, good to know. Property fields can draw enums automatically for us. All right, and there we go. Everything is working. Every second, I can shoot a ball. All right, let's go ahead and clean that up. We can get rid of this enum value index stuff. Key press required bool value, editor GUI property field key press, and change check. I don't know if we actually need this anymore since it's intelligently I don't think we, you know what, I'm sorry, we still need that because we want to immediately apply the savings after you uncheck that bool. So we're going to keep that. All right, let's see. Prefab to spawn, amount to spawn, frequency, key press. All right, good deal. All right, so far we have the ability, and let's add our multi-spawner back in here. I don't think we have a prefab for that one. So let's just add a spawn point. So at 0, 0. Let's remove that. Let me break this prefab. All right, and then let's add the multi-spawner to this. All right, let's get some game object positions in here. Let's just add all of these guys. You know what I would love to know? If anyone knows a shortcut on how to rename this stuff sequentially, like without having to painfully do it this way. Super annoying. Like I wish there was like I don't know if there's a shortcut to just instantly highlight the inspector name text. Okay, yeah, good to know. Yeah, I wasn't sure property field could do complex types, but I guess that makes sense. That yeah, like Unity Magic will take care of it. All right, let's see here. Spawn A, B, C, D, and E. We'll go ahead, just remove the colliders off these guys. We'll keep the mesh renderers for reference. All right, and then let's go ahead. We'll spawn out. Here's our multi-spawn, our spawn points. Let's go ahead and populate this. The enemy is going to be the enemy game object. The amount to spawn, we'll go ahead and just say 1. The frequency will be 1. We'll loop it. And then we have spawn points. So let's drag spawn A through E, put that in here. Alrighty. Okay, let's run it. And we should have, all right, so we got enemies coming down. All right, so now what we can do is we can actually create damageable types, collectibles, power-ups, all that fun stuff that you would be able to dynamically plug and play here. And let's go and just hide these objects. Oh, and actually, you know what? I wonder if this is going to break something. We have something called on invisible. I think on became invisible only gets called after it's been in view of the camera here, so we shouldn't have an issue here. But let's see. Let's see the multi-spawner, turn that off. Interesting. I'm not actually sure why I can still see these guys. Oh, it's because it's locked, right? Hold on. Okay. Let's make sure this still spawns out. I don't think on became invisible is going to affect it, and it doesn't. Good. All right, so the next logical one could be potentially a damageable component or a collision detection component that can provide an amount of damage. We could also create a generic health component where you can specify amount of health, and you could apply that to objects, right? And when they collide, we can affect, if a health component exists, then we could damage those dynamically. But let me see here. Oh, like strip numbers from end. Yeah, yeah. I've seen utility tools like that. All right, let's see here. What's the next packet we should create? Um, what ideas does everyone have? I don't know if we should tackle the collision one first, the health packet. What do we have so far? We got move, multi-spawner, set spawner, just individual spawners, update color, WSAD movements. We don't have a target follow system. Like right now, the goal for me, I think, is this just needs to be 2D. It's so that people with no experience with Unity could drag and drop these scripts and create unique interaction experiences, essentially. We could have things target an object, like move towards, like a move towards, but I don't know if we want to necessarily do that. Let's see. A trigger box script that just uses trigger, enter, and exit, and then stores a list of all the actors inside, then fires added, removed, or changed Unity events. Add a field for label. You can cover like 90% touch-based interactions. Yeah. I was thinking about earlier a interact object where you could have a Unity event fire off for its on trigger states. I just don't know how creatively someone would get with that, but an interact object would work. Let's see. What we at here? How long has this stream been going on? We got like an hour and a half here. Oh, we're at like 2 hours 20. Nice. All right, here's what we're gonna do. We're gonna take like a 10-minute break here. I'm gonna get some water, and then we'll pick up here. We're gonna create more packets. Let me go ahead here. I'm just gonna put up. Be back in 10 minutes. Hang on. What's cool is can you not do this in Google anymore? You used to be able to like tell Google, yeah, you can. All right, good deal. Sweet. Boom. Cool. All right, I'll be back in a second. All right, let's see here. um, a few components I want to create. One that I was just recently thinking about is just a simple text updater component. Imagine someone wants to create a game where you can catch a ball, for example. Like we've all seen that game where things are falling and you have to collect them. A text updater component would be really interesting, where you have this collection script, and I guess it would optionally support the ability to update text. The question is, like a score component, right? Like if I wanted to create a score system for my game, how can I do that based off of this concept of plug and play? Do we create a score mechanic? Like, do I create a prefab of like the UI and call it score, and it has a score script on it, and then we have a text updater that can communicate with that, or a score updater component? Maybe that's how we do that, right? Like we have our basically a score component that can keep track of scores, right? And then a Unity event potentially to update that score. Could be an interesting thing. Also, the health pack is going to be an easy one, so let's do that one first. So here we're going to create a health component. And inside of that, let's see here. All right, so inside of our health component, this one's pretty easy. All we have to do is specify the health, right? So private int health amount. And then once we specify that health, we also need a current health value. So we need to keep track of that for them. So they can specify what they want their health to be. Like it might be max health, for example, but then we also have a variable for the current health. All right, and then here we're going to say current health is equal to whatever the max health is going to be that they set. So let's call that max health, current health, and we'll serialize this too, just so that they can see it. Although what I want to know if we can do, I want them to be able to see this value, but not necessarily change that value. How can we do that? Let's see. A read-only property in the inspector. Do I need to do? There's a read-only attribute, property heights. Oh, okay. There's actually a read-only attribute. Ah, interesting. Okay, I didn't even know that exists. Sweet. Here, we can just do read-only. Read-only attribute, I think it is. Let's see, the read-only attribute lets you mark a member of a struct used in a job as read-only. Nope. This is read-only attribute. We had read-only and then serialized field. Why is it angry with this? It does not like that. Let's see. Yeah, I should be able to use the read-only attribute field. Oh, you know what? Okay, you know what? Hold on. We do need to we do need to do this. I think we have to create our custom property drawer like this, and then we can use read only. So let's do that. Up here, we're just going to say public class read only attribute. That's going to inherit from a property attribute. And hang on. Let's see. Fligit spiral up and away, and finally spiral into existence. Oh, nice, dude, love, that's awesome. Read only goes after private. Yeah, let's. I don't think this actually matters if it goes before or after. We'll find out. But hold on, I do need to create a property attribute, and then there we go. Read only serialized field. Okay, sweet. Nice. Yeah, annoying that I have to do this, but I guess it's required. Let's go into Unity and see how that looks. So on our player, we can add a health component to give our player some health. We'll also be able to keep it generic enough to add it to the enemy. But here, my max health, I'm going to set to 150. And my current health, I can modify it. So it's not actually doing anything yet. So the question is, why? Is it because read only has to come second? Let's see. So here, let's serialize the field, and then let's do a read only on it. Interesting if that's how that works. I guess that makes sense. It serializes first. But nope. Health script, 150. I wonder if is it actually reading that value though? Like it's changing it. Yeah, I'm not 100% sure what I'm missing here on this one. Maybe it wants to be on different lines. So serialized field, read only. The same line is private. That definitely shouldn't make a difference. The compiler, the way it reads it, shouldn't matter. I assume what you're saying is putting it read only like this. That should not matter. Yeah, I don't know why I can still modify that value. Serialized field, read only. What is this? Read only array attribute. I'm using my read only attribute class here. Private read only int. Oh, private read. Oh, oh, okay. I see what you're saying. Yeah, I guess I could only do. I don't think I need this then if I do that, right? Now, the problem with that, though, is I can't assign it. If it's a read-only int, it means you can only get that value. I just want to make it read-only in the inspector. I still want to be able to assign current health to max health. No, yeah, so read-only, I'm positive read-only makes it so that this value can only be read. I can't change it no more. So that's why it's giving me an error here. So we actually don't want to do read-only. I just want it read-only for the inspector. In the same line as private read only and health, no brackets. Yeah, this I thought there was a read only property field or attribute, but I guess I'm not sure. Let me see. How to make an inspector int field read only. This is the end-all answer. It will allow you to mark any field as read-only with a single property attribute property jar. It's partially based on this version. Also dispatches the property height based on how expanded the property is. All right, so we have this custom property jar type of read-only attribute. A read-only jar, which becomes that. He's doing extended stuff. We don't care about that. But I do want this read-only. Somehow this works for him. He's overriding the on GUI. He's getting the properties. I wonder if I actually need that. I wonder if I need that above our class. So now we have read-only, and let's see if that works. And nope, I can still freely modify that. Okay, let's see here. They're overriding the GUI. I really don't want to override the GUI on this. Type of show only attribute. Oh, hold on. Oh, this is another, okay, show only drawer, show only attribute. Okay, this is a separate property jar, that's why. Using your object, my class, show only. Let's see here. Man, I really don't want to do anything with the GUIs. That's annoying if that's the only way to do this. This should just by design. Begin read-only group. Interesting. I'm surprised this doesn't actually work out of the box. I figured it would because it underneath types. Public abstract class read-only attributes. Let's say if in the editor, but it works in, I'm sure somewhere if I could be useful read-only property attribute. So here's an abstract class of read-only property from property attribute. Read-only attributes. And then the property drawer. Yeah, damn, that's annoying. I do not want to touch any of the GUI stuff. Read-only attribute 0. Nope. Yeah, so the other alternative here is unfortunately another custom editor that would draw a property. The problem with that is I don't really want to create a custom editor just to do that, but essentially what I could do is private int current health. I turn it into a property, so we just basically say, I say public int current health. And we would have here current health. And then here we have a property for current health. And that's just going to go to that value. So here we have our current health. We assign it to max health there. This is a read-only property. The problem though is that you can't actually display properties inside here. So max health shows, even though we have a public property, it's not showing. If we go into debug mode, we will see that. And you'll see here that here we have a current health value that is read-only set to 0. We can get around this by creating another custom editor. I don't really want to do that, but I do want to display it. So maybe we'll do that where it's just like, hey, you know what, we're going to go ahead and read that value. Let's see here. So we're going to go into our yeah, you know what? We can do that. Let's redraw this. All right, so let's create our health editor. Oh, Odin Inspector is a solution for your problems if you don't want to create custom drawers. Oh yeah, yeah. I think you're right. Does Odin let you just draw? You can draw like auto properties and stuff in Odin. Odin's pretty cool. I know a lot of our students that are working have used Odin professionally, and from a custom drawer perspective, yes, I've seen some of the cool stuff Odin can do. It's pretty neat. The best part about Odin is if you can actually write custom editor scripts like this, Odin is just like a breeze to use. So I haven't used it, but I'm very familiar with it. I know a lot of our students use it. All right, here we go. Let's go ahead. We're going to delete this stuff here. Let's hop into our namespace. All right, we have our health editor, which is going to inherit from editor. Unity editor is going to get imported here. The first thing I want to do is we're going to override that inspector. So I think it's on inspector GUI. And it didn't fill that in like I wanted it to. Okay, here we go. All right, cool. So we're gonna not call the base because I'm gonna override it. What I do need to do is get those serialized properties. All right, so very similar to how we did the spawn editor here, where we have all of our serialized properties and then we assign them to go find them, the value and shit like that. We're gonna do that. So we're gonna just grab one of these real quick, put it over here. All right, serialized property. This is going to be for the max health value because we have to draw the max health first. And then let's create our on enable. And we're just gonna go back here. We're gonna grab that. So we're gonna say max health is equal to the serialized object find property called max health. So it's automatically gonna find that max health type, which is here. It's gonna know that, hey, it's an int, it's gonna draw it like so. All right, inside here, we need to make sure we include custom editor type of. And we're gonna tell it to override the health. All right, so here we have our max health. Max health equals a serialized object find property, and then we can actually now begin drawing that property. So if we go back to our spawn editor here, you can see how we did that using the editor GUI layout property field. And don't forget, we need to include an update here. All right, so we serialized object update the UI. We're gonna display our max health. Once we display our max health, then we want to always end it with serialized object dot apply. So if we modify any values. Okay, so let's see here. Go into Unity. Let's look at our player with the health component, and hopefully it's drawing the max health. All right, so here we go. So we got max health set to 100. I want to do a read-only display of that int value for our current health. So inside of our health script, we do have a property called current health, which grabs the current health. All right. So to actually display this, what we can do is inside of our health editor, we can actually define a temp value to use. So after we display that, we're simply just going to say int current health. And this is going to equal the editor GUI layout dot label field it's going to say current health and then current health. And I think it needs to be current health dot toString. Void editor label. Oh, and actually, you know what? Hold on. Just kidding, guys. that doesn't return anything. Editor GUI layout label field current health. We need to actually get we need to get that health property. So I need to actually do a we're going to do a runtime serialized property. And for the current health equals serialized object dot find property, and we want the underscore current health. Now, actually, I think we can use the actual property here, so I'm going to put that in here, and I'm not sure if it's going to let me do that. Argument cannot convention serialized property to string. Whoops. Current health. All right, let's see if that property is going to actually draw. So I'm going to use the property instead of this here, because I know that will work. So we'll grab that if we need to. But here, serialized property, current health. We grab the health, and then we display it. So editor GUI layout label field current health dot to string. Great. All right, I think we should be good. So if we select our player here, and we will see that we have max health. We're getting a null reference. I think it's because it doesn't like line 29. Yeah, I was worried about that. I think this is going to have to be current health. It wants the field, not the property. Oh, and then you know what, actually? I'm sorry, that's also, actually, no, hold on. Let's put that back to the property. Put that back to the property. We need to actually create an int value here. So let's call that int value equals current health dot value. There we go. Let's grab that value, and then here we're going to use value. And see if that works. Here's our player. All right, and no, still angry. So I think now it's because it's a property. So we might have to use the field. Current health, serialized object, and then here we're grabbing the value, the int value, and then we're displaying the int value. So I could have done here, I could have just said current health.int value.toString, but we're being explicit. All right, here's our player, and nope. Why is it giving us editor 29? What's it angry about? Object, it's null. So serialized property. So I have a serialized property. I set it to find property current health. Oh, you know what? I think it's because this needs to be serialized. Let's say, let's go into Unity. Let's see. Okay, there we go. Boom. All right. Who needs custom property drawers when you can just go through all the work to display a read-only int? But there we go. All right, so we got our max health set to 100. If we go ahead and run this, we can see that the current health should update to 100. I can't change the value. That's exactly what we want. All right, good deal. Something we can do is actually update it to match that value, right? So how do we do that if we're in play mode here? Basically, I should be able to modify that value using some editor code in the health script here. So there is, check for editor, let me see, check for editor. Oh, here, you know what? We can just do it right here. We can check right in here. So editor property field, we display it. And before we display it, let's check and see if it's changed, right? So here, we essentially always want to display it at the max health, I imagine. Yeah, I think we could, that's what it was. Thank you. It's that onValidate method. Yeah, we can actually use that one. So we can actually register changes, I believe, within this health script itself. And this function is called when a script is loaded or a value is changed in the inspector, called in the editor only. So at this point here, we're going to say current health. We'll say current health, which is read only, so useless there. But current health is equal to max health. So if we change the max health value in the editor, it should update for us and display that. And there we go. So if I update this to 150, current health is equal to 150. All right, cool. The next thing we need to do for our health component is it needs a generic damage property. So here, what we can do is we can say, hey, public void damage. And we can optionally override that with a damage amount. And we can actually let them choose like whether it's going to be an int or a float. Damage. Yeah, I think we can using generics. Let's go ahead. Okay, so what this is going to let us do is I can choose whether or not I want to damage an object by a float value or a int value. Thinking about it though, I'm not letting them set float values, so we might actually just be okay with getting around int actually. We don't need to use generics here. So we're just going to say int amount, call it damage amount. When this generic damage function is called, we basically are going to say, okay, cool, we're going to take the current health, subtract the damage amount, and then in here we can simply check if we are dead. So if it's less than 1, we're dead. For now, we'll assume we want to destroy this object. All right, let's see. Did you know you can actually display the current health as a bar, like editor.GUI.progress bar? Well, that's pretty cool. Here, let's try that. Let's see what that looks like. Here's our current health. So we do editor GUI layout.progress bar. And the rect position. Let's see. And then we can, what is this? This is basically the value to do it at. So it would just be what? Like current health, I think? It would be value. And let's see. Let's see how that looks. That's actually a cool idea. Oh, current divided by max, yeah. Ah, that's cool. Nice. Here, so value divided by max. All right, so current health, if we run this, and if I modify the max health, I imagine it should be a unique progress bar, but nope. Or I'm sorry, hold on. We have to damage our current health, which we don't have the ability to do yet. So here, to test this, we're just going to create a context menu that's going to damage us by 10 every time. So here is our damage method. We will just add a context menu here. But I don't know if I can pass in an amount actually on that method. So it might need to be here. Test damage. All right. Context menu is a super useful tool if you guys aren't using this attribute. It makes testing things really, really easy. On our player, I can essentially go to the 3 dots here, the main menu or the hamburger menu, and we're going to test the damage, and it's automatically going to call it. So it looks like something's wrong with the math there. It's very angry. Let's set 200. Current health. Test damage. It's going all the way down. I'm not sure what we broke. Current health minus equals 20. Yeah, Unity's got tons of... Dude, there's so much. It's a lifetime learning journey for all the cool shit that Unity can do. Yeah, you could probably choose a GUI style to change that color. Let's see. Current health. What is wrong with that one? Why is that not working? Value. So it's like 150 divided by max health, or 100 divided by max health. That should be working, right? Ninja Mindset, would you ask? Let's try casting it to a float. Oh yeah, that, possibly. Three-story account. What? Oh, okay. Oh, most people don't know. Oh, he's saying no. Most people don't know like all the stuff you can, all the cool stuff you can do with Unity's context menus and stuff. Yeah, it's a vast world of testing tools out there. You can go pretty deep down a rabbit hole with all the amazing stuff that's out there. All right, here we go. Player. Let's go ahead. Test damage. No, it's just instantly going down to 0 for some reason on that display. I don't know why. Max health. Let me see something. If we are at... Yeah, weird. It should be at point... I wonder if it... Oh, you know what? I wonder if we have to multiply it by 100. I think it's got like 0.9 down here. Does it need to be multiplied to get us up to like 90? Like 90%? Yeah, let's see. Let's do... Okay, so we damage ourselves, test damage. We're at 180, so it's working, but our rect bar is super messed up here. Yeah, I'm not sure what the heck is going on there. Yeah, here we will use that. Weird. I'm not sure what's wrong with the rect. The rect for it or something is just I'm not sure what's wrong. It's getting all spazzed out. Let's see. So current health 200. We test damage. Current health 180. Where'd the blue go? So I'm casting it to an int. Let me see. Value is an, I mean it is, right? So it's value is an int, so it's doing an int division here, unless value needs to be cast out as a float and max health as a float as well. Put them in here. Like, let's see. Might need to debug what that value returned is. Make sure this still works. Set to 100. Oh, there we go. All right, that was it. It was the float cast. Very cool. Yeah, there we go. Current health 60. Test damage. Boom. All right, good deal. That's pretty cool. Okay, sweet. So let's take a look now at our damage method. All right, so move that. And we'll keep that in there. All right, here we go. Let's see. We got start, current health, max health, public void damage, damage amount, current health, minus equals damage amount. So if the current health is less than 1, destroy that object. Okay, cool. All right, so basically what we have now is the ability for a user to say, hey, I want my player to have a health of 100 and the enemies to also have a health of 100 if they wanted to. So if we click on our enemy prefab, we can add a health component to that. And you can set the max health to the enemies to be 100. All right, so now we can get into interactables now, because we want to be able to obviously damage something. So if I wanted to create a damage, it's too specific to say this is my bullet that I want to damage something. Instead, it's an interaction that occurs, and when a trigger interaction on this object occurs, it maybe has a functionality to damage. Could be one thing that interaction can do. Like on trigger enter of this bullet, what's gonna happen? Trying to think how we can keep it super generic. Yeah. So I thought about doing a whole system where you could actually use scriptable objects and like create those values, right? Like you can create individual float values, but it's getting too into the know-how of you have to know the values, or you have to know what type of data you want to work with, versus we want to create an experience where you can essentially just drag components on and things work and you have like simple configurations. But yes, I'm a big fan of the architecture design behind using scriptable objects and the whole generic like float properties. They're pretty powerful. Yeah, if you're not familiar with what Jason's talking about, there is a Unite conference back in 2016 by Jesse Schell, who's the founder of Schell Games. They're one of the largest VR. We have a mentorship partnership with them, and they're one of the largest VR game developers right now on the planet, guys. And they heavily use a scriptable object architecture. It's pretty cool. Let's see. Trying to see how we should design this. All right, let's see here. So we got our health. We need to be able to create an interactable component. So for example, on my bullet, I want to have an interactable component. And it could be something where it needs to be generic enough so that it knows what to potentially interact with. Like, what are the dependencies, or what is it checking for? Yeah, no, it definitely probably is more flexible for sure. I'm just showing in Kotlin Dev by trade, didn't know if base object had a string representation. Oh yeah. All objects in C# can do that. Their kryptonite is that the values don't save after ending the gameplay; they revert back to their initial gameplay values. In the editor, all that data will persist on the scriptable object, only in play mode, right? Or on a distributed build, none of that stuff will. On a distributed build, that doesn't matter. Yeah, if you want data to persist, you have to get into saving and loading, like persist plays. Let's see. Okay. So on the bullet, they will know that in order for this object to detect collisions, that it's going to need to be a trigger event. So we can assume that the bullet is going to be an is trigger. The enemy can stay solid, I suppose, until it hits the player or something like that. But we might actually, just to keep it simple, we might work with only trigger collisions. So everything, for the most part, is going to be is trigger. On the bullet, to enable collisions, they're going to know they need a rigid body component. So we can just add that now. They'll uncheck use gravity. Okay, so now they have a collision object. Now the question is, I have my move component on it. I also want to create an interact component. So when someone interacts with this object, what's going to happen? Okay, I think I know how we can do this. All right, so on this bullet, we're going to create a interaction script. And we'll see how generic we can get with this. All right, so on our interaction script, we select our bullet. We're going to apply it. Where is this? All right. And the interaction script for now is going to have, we're basically going to be able to determine what we're going to check for. We can let them check for on-trigger enter, stay, and exit events in the future. All I want to do is focus on just this one damage element of it. So here, what we're going to do, let's just do on-trigger enter. We get the collider other. And we have types of interactions here. So we will specify, for example, let's see here, interaction type. And to keep it generic, we could do collision, like interaction type. I mean, they're all going to be collisions, but it could be maybe even damage, right? Like, what kind of interaction type is this? Damage, and that can be assumed that we are checking for a health component. So private enum, I think we'll start there. So interaction type, we will let them specify the type of enum this is. So interaction type equals interaction, oops. All right, so here we got our interaction type. We have a damage in here. And then we have interaction type that they can then set. And within the on-trigger enter, we will switch through the type of interaction this is. Some interactions, we could actually do a unity event, for example, right? So instead of damaging, I might want to do a unity event, and we could have it be even more complex from there. And I think I do want to get into that, so we'll take a look at that. But for now, we have our switch. We're going to loop through interaction type, and here we have interaction type. We have that case. Okay, so interaction type.damage, we need to know, hey, do you have that component? So here we're going to grab the health component. And there is a try get component here. And in order to use that, okay, yeah, we have to output that information. So to do this, I don't think we can just put it into, it doesn't return anything, right? When you do try get component. Okay, no, it just returns true or false, basically, if we got that. So here we're gonna have to do, so let's do var health. And it's not gonna like that either. Okay, so here we get a health component. And hang on, guys. We have to hop into our namespaces here. Okay, so here we have health equals null. And then here, this is basically a success call, right? So if we successfully grab the health component, then this is going to be populated. So we're gonna do a try get component, and we're gonna say and I thought it was like okay, yeah, out. Okay, so here, this should try and get that component. So if they don't have a health component, then this is basically not going to work. If you expect them to act, yeah, need no friends. Let's say it's only a problem if you expect them to act differently. It's infinitely easier to write a few lines of JSON saving a line that, and the line after only fire if the health exists was gotten and can be accessed by health. Yeah, so in this one here, we assume that if you have an interaction type damage, we can basically assume that, hey, they want to communicate with the health component. We need to make sure that that object has a health component. And if it doesn't, so if success is equal to false, we need to debug.log an error. No health component. No health component found. Let's see here. So we get success on that health component. If success is equal to false, debug.log no health component found. Otherwise, what we're going to do is access that health. And we'll call that damage method. And then the damage amount. So we might need to do a custom inspector here where based on the drop-down selection value, so if it's damage, then we show a damage amount. Because for now, it's just going to be right here. So we'll create another editor script for that. And then here, we're going to pass it in. Let's see, Jason, you said you don't have to do it twice. I don't see your out example. Let me see. What am I missing here? Oh, yeah, you're right. My bad. We don't need that. It should just be this. Other.try get component health out the health. There we go. Yeah. No. It was working, but it would have been a different instance of it, I believe. So this is the proper one, because we have this health null success. We output health. If success is false, we log an error. Else, we're going to go ahead and damage by some damage amount. And the damage amount here is angry because it takes an int. Okay, and then I want to make sure that they can't set that to a negative amount. So damage amount, you could do a range. How do I prevent just one side of that? I'm sure there is. Let's see. If I do a range, I have to also put like a max value. Can I do range without a max value? Oh, there is a min attribute. Yeah, let's look at that one. Ah, here we go. Attribute used to make a float or int variable restricted to a specific min. Awesome. And we'll set it to 0. Cool. If we click on our bullet here, we have an interaction type damage. We need to make sure we can actually see the others. And let's see here. And if we try to go negative, it sets it to 0. Okay, good. All right, so here, let's say that the interaction on this is going to be 10. So we have our gun. We have a damage interaction element. All right, so we know we're damaging damage amount. Let's go ahead and test that out. This on trigger enter should be called on this object. We're going to grab the other objects. We're going to handle all this stuff here. So we'll test both the cases. First, if we select our enemy here, let's remove our health component. Actually, no, here, we'll just go ahead and play this out. All right, and let's see here. Let's just undo your health component real quickly. Okay, and there we go. So no health component found. It did not pause the editor like I wanted it to. The reason for that is because it didn't do a debug.break, but it worked. So it logged an error and then debug.break. And that's going to automatically pause the editor. Now we can go ahead and test the actual damage amount. Oh, this is the multi-spawn game object. This doesn't actually need anything. Okay. Let's see here. So on that first enemy that we're about to shoot here, let's go ahead and watch its health value. So if we go ahead, I'm gonna set, and no health component found. I believe it just collided with myself. So we're going to go ahead and set up collision matrices on our player here. Basically, our player has a collider and our gun has a collider, and they need to ignore each other. So let's create a layer for our player. So here is our player. And we'll change all the children, and then we'll go into edit, project settings, go into physics, and you'll see here that we have some collisions here. The player layer will not collide with each other. So all we have to do is just uncheck that, and we should be okay. Alrighty, we're gonna set this guy's speed to 0 so he can't move. And then let's go ahead here. We're on that enemy. His current health is certainly set to 100. I shoot him, and we still have a no health component found, which is odd because this player is set to layer, the gun is set to player layer. Why is that happening? Let's see. Actually, hang on. Interaction type, on trigger, enter, collider, other. And we both have a health, although interesting, even if anything, it should actually be damaging ourselves. We have a health component on our player. The bullet itself has a spawner and it's coming out. And then it also has, oh weird, hold on, what just happened to our, okay, yeah. The bullet has an interactor, and I think it's okay, that's what it is. The bullet, oh, okay, sorry. We don't want the player to ignore each other as well. The bullet needs its own layer. And we're gonna tell the bullet to ignore the player for now, which will be problematic when the enemies fire, but we'll get to that when we get to it. But just to get it working, let's select that, go back into the matrix. And we're going to go ahead and say that the bullet and the player do not interact. Test it out. And here on our multi-spawn here, we're going to do, we're not going to loop, we're just going to get one enemy. Okay, so this guy here has health set to 100. Let's go ahead. And we're still colliding with ourselves. Make sure the bullet is set to a bullet layer. Okay, there we go. All right, good deal. So let's go ahead and just run that again. We're going to check on that object. So here we go. It's got its current health. We'll set its speed to 0. Let's go ahead, and when we shoot this thing, we should see that the current health should go down probably by 0, since the damage amount is 0. And actually it went down by 10. So that means that on the bullet, the damage amount was set to 10. All right, there we go. So we actually have that working. And we can go ahead and we should be able to kill this thing. So if we go ahead and shoot it a few times. 40, 30, 10. All right, and then it disappears. Awesome. Something else here, these bullets aren't getting cleaned up. We are definitely needing to, let's go into our, what is it, our move class here. And we're essentially just gonna do void on became invisible. All right, on became invisible. Destroy the stock game object. Good deal. Alrighty. Here, hold on. I'm just gonna modify. I'm gonna remove that log from our spawner editor. There's a log in here. What's getting called? Oh, maybe not. Oh, spawner. Okay, so far we have a working interactable with a bullet. Now the question here is, these bullets, they're being fired from the player, but if we wanted to support the enemies to fire, could we potentially do the same thing? Because if I was one of these students, I would imagine that I could take an enemy, I could add a move component which moves it down, I could add an interaction component and add damage, so that if it hits the player, then it's going to damage me. Now this actually will probably work just fine because this is an enemy object with a box collider colliding with us. Now this object's going to need a rigid body, but it's just going to collide. If it wanted to shoot specifically, this is where I think we would have a problem. If we added a spawner to this, if it runs into the player, I don't think there's going to be a problem. But if we were to let's see here. Hey, what's going on, Paul? Paul Kantowski. Let's go ahead and say, let's add a spawner element to this. And we wanted to use the same bullet prefab because that makes sense. We're going to spawn one bullet, and the frequency is going to be like every 5 seconds. And we're going to loop it. This is automatically going to spawn, and then it's going to have a bullet. Oh, you know what? They're going to need individual bullets for this. They wouldn't be able to use this one, right? So this actually maybe solves that. There's a bullet prefab for the player, and then there's a bullet prefab for the enemy, because one's going down and one's going up. So I think that's going to be okay, actually. Yeah, we shouldn't have to worry about that. So we have down, health, and okay, good. I didn't add those other properties, I don't think. On this bullet, we have move and interact. Okay, cool. All right, I think that's actually going to be fine. You would be able to do that by creating a dedicated enemy bullet, and then they could remove those collision detections. Okay, so far, if we look at our multi-spawn here, what do we have? Enemy amount to spawn 1, frequency once, and we'll loop that. And then here on my bullet prefab, I'm going to choose the the damage amount here. Let's set it to 100. Okay, and we just got a no health component found. So I believe that's because, and let's actually fix that. That was the enemy hitting the player. So on the enemy, we now have an interaction script, and we'll choose it to 100 as well. The problem, most likely, is that no health component was found. It hit the gun, not the player. And so if we look here, the gun has its own collision. I don't know if the gun needs its own collision, so we can actually just probably disable that collision on the gun. And if we test that out again, let's see. Ooh, something janky is happening here. I'm not sure what I screwed up. Let's see. Here's our multi-spawner. Something's spawning like right in front of us for some reason. Oh, it's this enemy. That's why. There's an enemy in the scene. Okay. Now I think we're still gonna have that problem because, so here's an enemy right here. And did I set their speed to 0 or something? Why is he not moving? Or who is that? Oh, that's just our multi-spawner. All right, and now we're not spawning anymore. I think our weird, I think our on became invisible is acting up here. Yeah, we could actually do that too, right? Like I think on this, I don't know. It would require, yeah, we could do something like that too, Lem. It's just a matter of adding the ability to make it generic enough to choose the direction of this bullet component. But I don't want to create a specific bullet component. All right, hold on. I'm not actually sure what just broke in our thing here. We have WSAD components. We have a set position and a health script. We have our multi-spawn, which takes all these spawn points. And we're going to mount to spawn. We're going to spawn one enemy at a rate of 1, and we're going to continuously do that among these positions. Why is it getting cleaned up like that? Inside of our, I believe on the enemies, I think something is cleaning them up early. Okay, let's test that. Something with on became invisible is getting called when it shouldn't be. Yeah, weird. I'm not sure. It does not like that for the move components here. I'm gonna remove this out for a sec. Oh, I had, well, weird. Did I have 2 of them in here? I did. Oh, on became visible. My bad. Jeez, that's why. We were basically saying destroy yourself as soon as you become visible. All right, cool. All right, so without any coding, this is the parts that we're up to. We can literally plug and play our way to creating this. Probably enough interaction to where we could do something even custom, like you can create an object where you have to catch these things and you get a score. So I want to think about this potential score concept, but for the most part, I think this is okay. This is a good start. We have our health component, we have an interaction component, a move component, a multi-spawner. The only type of interaction right now is a damage interaction. I don't know what other interactions there are. The interaction could be, you know, just like turning off. It could essentially be a generic Unity event even. I don't know what else. Hey Tom, are you still tuning in? Curious if you think from who this is for, do we have enough interactable components here to get an idea of what you can do with Unity? That's the question. Huh. Let's see. And then if the player here, let's test the enemies running into the player here. I think we're gonna run an issue with our gun. If an enemy hits us, okay, nothing happens. And the reason for that is because they do not have an interactable component on them. So let's go ahead here. Yeah, no, I think Tom dropped off for a minute. Let's add an interaction here. So we have a damage interaction. The damage amount is 100. It's gonna hit the gun and it's gonna complain. Oh, just kidding. It needs a rigid body. Okay, there we go. So it hits the gun and complains. So I knew that was gonna happen. To solve that, I'm wondering if on the gun we really need that collision. Like the simple fix here is just remove the collision. Or, you know, could we create potentially an array of colliders to ignore? You know, like maybe it's like, hey, ignore this collider if you run into it. I don't know. For now, we'll keep it off. Cool. No health component found on that enemy for some reason. Hold on. Let's see. We seem to have broken that. All right, here we go. So we're going to get a collision here. All right, so the player gets destroyed because we only had 100 health. So that worked perfectly. Let's now reshoot these guys because something is broken there. No health component found, but I shot an enemy and he does have a health component, and the damage on my bullet, which is an interaction, is set to 100. So what happened there? It's saying no health component on the enemy, but there is. It's right here. All right, so let's go to our multi-spawn here. We're gonna stop the loop. Let's just get one in there. All right, so here's our enemy. We currently have, let's see, 100 health. It has a move script to go down. Its speed is 0. And it has an interaction script on it. Oh, and that's why. Okay, we are conflicting because I am triggering my bullet. Like, I'm going to fire it. As soon as it hits, this interaction script is actually going to get triggered. And my bullet does not have a health component on it. So we need to be able to support the ability to ignore certain types. Like, should two interactions objects be able to collide with each other? The answer is probably yes. Man, hey, see you, Paul. That's gonna be a tough one. basically we can tell. Trying to think how we can keep that generic enough. Because now it's upset. So if the enemy can damage us, then we can't damage it. Because there's a conflict between the interaction here. Might be a problem for later, but let me see here. So if we select our enemy and we turn off the interaction here so that it can't actually interact with us on the enemy. Let's run this again. We should be back to where we can actually damage the enemy. Yeah. So, that's gonna be interesting. Yeah, that's gonna be an interesting call. I gotta decide how badly do we want to enable that, or if we have enough here. Something I actually want to think about is what other things could we create other than essentially the space shooter concept. The goal of this is that it's kind of generic. Like we have these plug and play components to help you make a very basic game. Like what else can you do to just play around and mess around with things? For the most part, I think you can pretty much do everything. Something that I think we are missing is we have the ability to make things collectible through this interaction damage, but we don't have a way to necessarily update score. So I might take a look at that. But we've been going now for, we're at like 3.5 hours here. I'm gonna take a break here, come back to this. We'll do some more on this. I think it's at a point where I think the end user gets the idea of like, hey, you can the whole purpose of this is you've never used Unity before. Here's how the component system works. You can plug and play your way to creating interactions. And then the next set of stuff, right, is actually learning how to write all this stuff. Junkyard dog, grab the bumper of the passing car. Let's see. Like, if I wanted to, could I recreate Pac-Man? That's what I think we'll do when we come back here. I'll go live in a little bit here doing that. But yeah, we're going to take a short break, and then I will see you guys later.